Hello there, welcome to End-to-End Solution Architect session. Today I'll be talking about data ingestion. It is our data lake series and I will be discussing multiple approaches of data lake. So as you see, as a part of our data ingestion, we have this big complex architecture. But in this session, I'll be covering approach 1, which is to create a real-time mock data stream with custom API. So as a whole, our data lake series will talk about the multiple approach of this whole design. But don't worry, it is a multi-approach combined design. So when you are actually creating any data lake solution, you will not be using the whole architecture because there are multiple options are combined in this design. So as an example, if I show you that in this session we will be covering the approach 1 of data ingestion, and in approach 1 it is basically to create a custom API to simulate real-time data streaming. Now let's understand why we are creating a custom API to simulate real-time data streaming. The reason is when you are creating any POC, every time you don't have a source system which will provide you real-time data streaming. Suppose at that point you are not able to integrate Twitter streaming or any other third-party streaming solution. So in this approach, I'll be showing you that how can you create a custom API to basically create mock data or simulate real-time data streaming. Well, now let me explain this architecture. This architecture is also a combined multi-approach model. So as you see that approach 1, 2, 3, 4 and 5 are different approaches. So it depends on what is your scenario or business requirement. Based on that, you pick one approach which fits the most and carry on with your data lake solution. So again, in this session, I'll be talking about the approach 1. And our approach 1 is basically the simplest one where we will be creating an Amazon API gateway. It will call AWS Lambda, where we will be generating a mock data or basically a mock JSON file, and once it is generated, it will be ingested in Amazon S3 raw zone or landing zone, and we will invoke this Amazon API gateway through a custom Python script. Now you can invoke this through your simply browser, or just to iterate or make it real-time data streaming, you can create a loop in Python and just iterate or invoke this Amazon API gateway multiple times. Now before I jump into the actual hands-on session and show you every steps one after another, let me show you how the end solution will look like. So as I said that we will be creating a custom Python code which will invoke the API gateway. So I'm using Google Colab, and Google Colab is just to use the Jupyter notebook. Okay, so if you have your Jupyter notebook, you can run your Python, or if you are using your Google Colab, that is the easiest solution you can. So this is my simple code where I am importing the request and I have pasted my API URL, which is actually the API gateway I have created, and just printing this response. So if I click over this icon, it will run, it will invoke the API gateway and is showing this JSON message. Okay, now this JSON message is basically we will be creating, or it is our custom JSON message. So you can make it as complex as you can, or you can make it as simple as you can. It depends on you, and I will show you how you will be able to create this JSON message in your Lambda function. Okay, now it is the simplest call of this API URL as you see. Now if you want to iterate this API and want to generate a stream, data streaming. So what I am doing, I'm just simply creating one, defining one for loop and running this for loop for 10 times. So if I execute this, it will show that it is actually creating 10 messages. Well, now once this 10 messages has been created, now if I go to my S3, let me go to my S3 over here. So I clicked over the S3. I'm going to that particular bucket where we have my raw zone over here, and under streaming data, you see that it has just generated this message JSON files over here. Okay, let me go to the diagram once again. So as in this diagram, I have explained that we will have a custom Python script which will run and invoke the Amazon API gateway. The Amazon API gateway will trigger the AWS Lambda function, and the Lambda function has the custom JSON message which we are creating, and ultimately it will push that message file into our AWS S3 in raw or landing zone. Okay, so let's move. Here I am in the S3 bucket, and if I just simply download one message, I can show you how it looks like. And the message looks like this, as exactly I was showing in Google Colab. So as you see, the message over here, and this is the message, was saved as a file inside AWS S3. Now it is our practical part of the session where I will be showing you every steps one after another. At the first step, let me explain that S3 bucket structure. Now, first of all, it depends on your requirement of your organization or your business case that how your S3 bucket structure will be. But in general, for a data lake, you will have a S3 bucket, and inside that you will have multiple directories over here. So as you see that I have created single S3 bucket, and inside that I created two folders, raw zone and clean zone. As per your business requirement, you can generate or you can create this clean zone and raw zone completely separate in two separate S3 buckets. But in our tutorial, we have created two separate folders into a single S3 bucket. Okay, now raw zone is basically the landing zone where when you are ingesting your data files or you are receiving data for multiple internal or external systems, you are actually dumping all data in raw zone at the first point. That is the reason it is called raw zone or landing zone. Now you can divide this raw zone based on the category of data you receive. Sometimes you receive batch data, sometimes you receive streaming data. So we have further classification of this raw zone, two new folders inside raw zone. One is called batch data, another is called streaming data. And I have divided further the streaming data into system A and system B or something like that. So it means that you are actually separating your ingested data based on the system. But as a whole, it is your landing zone or raw zone. Now, similarly, when you are actually cleaning your data and storing in a clean zone, then the same kind of hierarchy you can maintain. So the clean zone also has the batch data and streaming data. Streaming data also has system A, B, C, whatever you need. So in system A of clean zone will actually contain the all processed and clean data which you took from your system A raw zone. Well, so basically, let me take you to AWS S3 and create these buckets over there. I'm logged into my AWS console, searching for S3. Just give a bucket name. Suppose we are creating E2ESA data lake demo 01 US East. I'm not changing anything, keeping it block all public accesses. That's fine. Not enabling the versioning as well. At this point, I'm just adding a tag over here. So the tag name is project and it is E2E data lake demo 01 it we asset. Okay, add this tag, that's fine. Okay, now I'm just clicking on create bucket. So our S3 bucket has been created for our data lake demo. As I said, now we'll be creating few folders. The first folder is raw zone. Now there is no fixed name for this raw zone or clean zone, or you say landing zone or atomic zone. It depends on you. But to standardize this functionally, what the folder does. So by this methodology, I call it raw zone or landing zone. So just creating this raw zone, a folder. In same label, I'm creating clean zone. Now inside raw zone, I'll be creating another folder for our streaming data. So suppose streaming data. And I'm not creating the batch data because at this moment in this tutorial, we are not talking about ingesting any batch data. Okay, so just moving out, and in clean zone, same way it is streaming data. Okay, so we have done our S3 bucket structuring part. Well, let's see what are the tasks we have to complete. Now we have to complete these tasks one after another. The first task, which was create S3 bucket structure, we have completed. Now the next task is create a service policy for Lambda. The reason is, in few minutes we will be creating a Lambda function which will basically generate the mock message and push it to our S3 bucket. That's why we have to create a service policy for Lambda. The next will be creating AWS Lambda function for simulating JSON message. The next, create Amazon API gateway, the REST API basically, and link a trigger to above AWS Lambda function. So basically when we invoke this REST API, it will trigger the Lambda function, and write a Python script to invoke the REST API iteratively. So basically you can generate a constant data streaming and ultimately test the custom message API. So let's move to our next phase, where it is create a service policy for Lambda. Let's search for IAM. Click on create roles. Select AWS service. Search here for Lambda. Select Lambda. Select next. Well, now it is asking for add permissions. Since the Lambda will connect to S3, so that's why I am just searching for S3 and adding Amazon S3 full access. Now, let me emphasize this way that you should not add S3 full access or any service full access when you are actually creating a solution for your production environment. Just we are creating this as proof of concept. That's why simply I am adding this permissions. Otherwise, you have to harden the permission particularly to the resources. In our case, particularly to that S3 bucket only. Well, so I'm just clicking over next. Here is our trust entities. Now I'm just giving a name. It we say data lake Lambda data ingestion. Okay, not updating this description at this point. Our S3 full access has been added. Adding one tag project. It we say data lake demo 01 and clicking on create role. Perfect. Our role should be created. I'm just searching our role. It we say data lake Lambda, our role has been created over here, as you see. Well, so our second task is also done. Now let's go to Lambda. Click on create function. Now at this moment, let me give a name, AWS data mock data ingestion. The runtime, let's select Python because I'll be writing the code in Python. Now change the execution role because we have created one role for this. And I have selected the role we have just created. It is a data lake Lambda data ingestion. Not changing anything, just click on create function. Now at this moment, as you see that it has created a skeleton of the Lambda function, and here you have to write your Python script as Lambda function. Now let me take you to our E2ESA GitHub, where we have all these tasks and the code already available for you. Now at this point we are creating this Lambda function, so I have kept this Lambda function code for you already. So if we just copy this code simply, and I will explain this code to you, just clicking over raw and copying this whole file and just simply replacing it over here. So at this moment I'm just clicking on deploy. It means that it will save your Lambda function in the Lambda you have created. Now let me go back and describe or explain this code a little bit to you. So what happens in our Lambda handler, we are basically creating this data directory. It is nothing but a JSON format which we will be using as the message format. Okay, so you can make this message format as per you, maybe the simplest way, only this part. You do not need the multi-hierarchy message in this case. Okay, but we are just generating a message, so I am not going deep into it. So what is basically doing it, message created at, and it is actually generated from a timestamp. So it will take the current timestamp. There are few things that we are using a random function to pick few countries at the place attribute. So you see that we have few functions like create hashtag, which is basically generating the hashtag or picking up random hashtag and putting it in the JSON format. But it again depends on the JSON format you are using. If it is very simple one like this user part, this part only, then we are just creating a user ID as a generated random ID or random integer from user ID and assigning in ID attribute. Okay, so let's move forward, and once this data directory has been defined, what we are doing, that we are creating a data string, ultimately creating the connection with S3 bucket over here, and here we are putting the S3 bucket name. So let's go to our function actually and replace the S3 bucket name which we created actually. So I am opening this S3 to get the S3 bucket, and in our case the S3 bucket name is this. So I'm going back again and just updating this S3 bucket name and just checking that whether I have any other places where I have to check the S3 bucket name. Okay, no, because I have changed the S3 bucket name and I have this, you see this as a key, raw zone / streaming data / message hyphen, now the string where I am converting the timestamp into string. So I want to concatenate with the message string to create a file name basically, which will be stored in our S3 bucket. Okay, so rest of the part is fine. Now I'm just saving my message. Now let's give a try and test whether this function is running or not. At this point in our raw zone, we don't have any file, it is completely empty. right? So I'm just testing our Lambda function. To test that, click on test. Just to create a new event, so add test event sharing private. Do not need to change anything, just save, because we are not passing any parameters over here. Okay, now just click over test, and it says test passed, and it created this response. So basically it generated one message, and we should get that message file in our S3. So if I do refresh, we should get this. Perfect. As you see that we have our message just created. Now let's download this message. This is our message created, okay, as the same JSON structure we mentioned in our Lambda function. Now I'm back to my Lambda function once again. Now our next task is basically create a REST API which will invoke this Lambda function. So let's go to API gateway. Simply click on create API. Click on REST API, not this private one, REST API. Click on build. Click over REST, which is by default. Let it new API. Give a name. It will be as a data lake API data ingestion. Let it be endpoint type as regional. Create API. Now click on this action. Click create resource. Here give a resource name, suppose message. Click create resource. Now at this point we have to create a method which is basically called it, and we know that we will be using only get method. Basically we want that when we invoke this REST API, it should trigger our Lambda. So just selected get for this, and integration type is Lambda, and our Lambda region is US East 1, and I'm just selecting our Lambda function which we just created a few minutes ago. Clicking on save. So it is asking you are about to give API gateway permission to invoke your Lambda function. Yes, we want. Click on OK. And our API gateway is almost ready. Now what we have to do, that let's click over action. Click on deploy API. Create a new stage called suppose prod. Click over deploy, and if you go over here, click over this get, and then you copy this invoke URL. Now at this point I want to emphasize that you click over this get and then only copy. If you click over this prod, it will not take the whole URL and it will not work. So click over this get and copy the whole URL form here. Now before testing this URL, let's go to our Lambda function. Here we are in our Lambda function, and as you see that once we created and integrated our API gateway, now it is showing in our Lambda function that how it is integrated. So the trigger, one of the trigger is API gateway. So once we invoke this API gateway, it will trigger this Lambda function. This function will be executed, and ultimately the message will be generated and it will be pushed in S3 bucket. Okay, so now let me open an incognito window where I'm just opening this REST API we have just created, and you see that as a return message, this API is giving the output the new message. Okay, so let's go to S3. So at this point let's go to S3 bucket. Here I am just clearing all these old messages over here just to give a fresh testing. Okay, so we don't have any message in our S3 raw zone streaming data. Now let's go back to our API testing. So here now I am again refreshing this API, so it should generate one more message in S3 as well as it should show over here. So it has generated. Now let's give a refresh over here and it has created that. Okay, now let me delete it once again and let me show that why I am deleting and testing it again and again. Well, so let me copy this API now, and as I said, we'll be using a custom Python script to test it. So let me replace this API with the API we have created. So it's like this. Okay, so now our API has been, I have replaced this with our new API. This is our code, and this code is same way available. Run the Python script in Google Colab. So it is the same way available, which I'll be sharing the link. So here let's click over this icon to run this cell, and it has started invoking. It will run for few iteration, and we will go back to our S3, and as you see that it has just created for that data streaming. So you do not need to click manually again and again. You just run a loop and it will create multiple message for you. So at this point, let me reiterate this very quickly, that what we did, we actually created Amazon S3 folder structure for raw zone and clean zone, and we created a Lambda function which will basically create a dummy JSON message and it will push it to the S3. And for that we created a service role for Lambda as well. Next we created an Amazon API gateway which will basically trigger the Lambda function, and ultimately a Python code to invoke that Amazon API gateway. So it was our approach 1 out of 5 approaches for data ingestion. Now in our next few sessions, we will be discussing the other approaches one after another. So the approach 2 is basically ingest data from real-time streaming systems such as Twitter API or cryptocurrency API. There are few APIs, platforms, if you register with them and use their credential, and you can ingest those real-time data streaming into your landing zone or raw zone for your data lake purpose or for your research or analysis. And same way we have approach 3 where we have planned to show you the real-time data streaming using Amazon Kinesis. The next one with Amazon managed Kafka. And the fifth one, we all know, it is basically just uploading data manually into your S3. So there are 5 approaches so far. In this session, we have completed the approach 1 only. If you have any queries, feel free to email us or write your comments in the comment box. If you are interested in any IT role-based training program, you can go to our website itwisolutionarchitect.com and browse these trainings like AWS Cloud Practitioner, Azure Fundamentals, Cloud Digital Leader, Terraform Associates, like this. Also, there are few boot camps which are classroom coaching we conduct. If you are interested, you can check the link and you can register for that. For any queries, definitely feel free to comment or email us directly. I hope in this session you have learned few things, and please stay tuned with us for the next session in our data lake series. See you in our next session. Thank you for your time.